Well, we're back at it. So, I've got a bunch of updates to the car I was going to show you guys, and I made a mistake of wearing my status earbuds, which apparently have a terrible microphone for doing any sort of recording. So, I'm going to send those things back and see what they can do in regards to picking up a proper voice or whatever it is. The bassiness missing on the microphone side, horrendous. So anyways, here we are right now. We have the intake manifold with an extremely tight, I'll get this out of the way, the clearance there in any direction is just wild. You guys might have noticed the flake that is in this thing. It's actually really cool, unique color. This color, this like 5000 Kelvin, does not do any of this car justice. You guys have seen the pictures when this is in a natural daylight, and it is beautiful. This color is just unbelievable. But anyways, I'll show you where I'm at, how I did the fuel system, and how I intended all this to work out. So this fuel system, we have 1700 primaries, 4 2600 secondaries. And the thing is that when you have a very large injector, when that opens up, the pencil opens up, the pressure differential across a long rail like this is going to be a large pulsation coming into the system. Now, the Weldon A2047 is about twice as big. See, those are dash 12 lines that are standard on the fitting. Twice as big as a standard pressure regulator. That means the diaphragm there can handle a lot of pressure differential, up to about 150 psi base pressure, which is a lot. But despite how good that is, PTFE lines are very hard. A standard rubber line, if we were thinking about like factory rubber lines, they can expand and contract very well. They'll have like essentially this sort of pulsation damping from itself. That's why rubber is used as a great noise insulator. Butyl, same thing. So on PTFE lines, it's a hard plastic. Vibrant PTFE in particular is a non-corrugated plastic. And so the bend radius is not nearly as good as something like a Goodrich 910, HS79 from XRP. Brown and Miller has their amazing setup, their gold line. But anyways, it is not as good when it comes to flexibility. And the corrugation would actually help part of the damping. Because these are solid core PTFE lines, which I think I have, I can kind of show you guys right here. So this is just a solid piece of plastic, most likely extrude honed, or I doubt it's injection molded, but anyways, this does not handle vibrations very well. This is essentially a hard line. So what happens is the vibration from the fuel pumps coming up into the system is going to be exacerbated without a damper system. So this car has a damper on the secondary rail, which is now modified, and the primary rail. So my damper, I'll move to the other side and show you guys. My dampers ideally would have been on the feed side for both of them. So one damper is right here, one damper is right here. And because I could not fit the intake manifold and the damper right here, or I couldn't put both dampers off of this dual dash 10 fitting here. Let me get that focused. This dual dash 10 fitting here. that would have been great to have. These are 8 ORB, so it would have been dash 10 to 8 ORB spitting out, and that would have divided into lower and upper rails accordingly. That was not a possibility, simply because of the restrictions underneath the intake manifold and clearancing around there. When we had to do the fuel rail modification, which is right here, and I do have a copper paint pen to kind of clean this up. When this was chopped down to fit, that means the center piece now has an angle with a dash 10 fitting. Phil did such a perfect job. I'm amazed. Again, we squeaked by. Like, the clearance there is just wild. We got very, very, very lucky. So, because everything on this car is so large, this is double aught gauge, this is 5/8 line, dash 10 is 5/8 line, so all these are very, very, very large fittings. The room that we would normally have in most setups is taken up by just the actual girth of the lines. They stack, they compound. So even something as simple as feed and return lines are huge, right? And that's just kind of the downside of being a Captain Overkill kind of asshole that I am. I would prefer having less pressure loss from rear pumps to the engine. And even though I've got ample fuel pump to handle everything of all my dreams and needs for this turbo, which is huge, I don't want to have a loss of pressure, which is compounded significantly with smaller lines, if I can avoid it. So the dampers are necessary to handle the larger injectors opening at the same time, especially on a longer rail, because you have to figure out pretty much the Helmholtz frequency of this with fuel, because the fluid. It ends up being the point of when these things open up, there's a big drop in pressure as the injectors open. So when you're talking, what is it? With fuel pressure brought up, 17,000 cc's a minute of fuel. It's a lot. So overall, everything has worked out for clearancing except for that. I'm waiting for a 150-degree dash 8 fitting here. I've got a swivel fitting on the back here for clearance of this dash 4. And just a few small odds and ends, but I was able to do the motor mount differently. I shaved it down. I used a little neoprene 60,000ths of an inch spacer, and now my alpha locks are perfectly aligned. So these guys are doing their job. And for those who don't realize, this is a Garrett G42 1200 compact. It has an anti-surge drive-by-wire with a direct dump vent. There's a CWA 400 electric water pump. I retained the water pump housing, and then my coolant line for the turbo is a cold source directly off the coldest part of the pump, which will go back around to the lower end of the turbo and back over here, which goes to the wastegates. So the turbo is cooled, the wastegates are cooled, and then everything returns back to the back of the motor right there. So very tight, but very well thought out, I think. So tomorrow, the game plan is to do the double aught gauge for ground and for power. The power is going to go over down to the starter. It's going to daisy chain up to the alternator. So there's 2 main power wires. The ground, this is a little tricky because the way this swivel lands, I don't have room to space things out to go over AC and that close to the exhaust. I don't have room to go up. I don't have room to go down, really. So the grounding is going to be real tricky on this. But the ground essentially has to go from this point here to the center of the engine, to the body of the alternator of the 270 amp DC power alternator. So that's going to be a point here, like a start point. And it also has to go to the body of the bolt of the starter, which is the long through bolt in the back. So that is a very, very space. I mean, you guys can probably see the wires right here next to that house that I made. The wire's huge. It's that big. So we're talking 7/8 of an inch minimum. But we're going to do some -4 lines next. I'm just waiting on the last couple fittings. All the fuel system is done for the most part, except for this return line here. And that will be trimmed down, going straight across and right to that fitting. Then we're going to have oil pressure 90. It's going to be 150 right here. I'm sorry, 180 right here. This oil pressure sensor goes this way. And if you guys are wondering why the sensor is mounted on the bottom here compared to the top, well, let me explain. These connectors, when we were to have these sensors on the top here, the connector and the sensor body, the wires would end up being really close to this hood line right here. So sensor, connector, you're right there. So you really have to put a nasty bend on that. So the more effective way is just making the fittings go on top. This can go anywhere it needs to underneath, and the connection's very easy. So I prefer it this way because it's also easier to find a leak. So if any of these are leaking, I feel like this is eye level. This is much, much easier to see versus if it's underneath, it could be dripping down below and you'll never see it. So I really prefer doing it this way. Glad I did it that way. And yeah, that'll be oil pressure, fuel pressure, map before throttle body, map after throttle body. So that's the 4 sensors right there. So gauge, atmosphere, atmosphere. So that's that. This car has dual knock sensor, oil pressure on the factory gauge cluster. It's a brand new dipstick that I've been out of the way when the charge pipe goes through here. And it's a pretty big hefty boy. It goes through this spot. This is an ugly problem area that I'm afraid of scratching my charge pipe on. So I've kind of tweaked this in a few different spots, a few different ways. And I would love to brainstorm a different way to do this, but for the time being, the power steering line will go down at a 60-degree angle. It runs at the front and goes into the power steering cooler, which is one of the small CSF race ones in the front. As far as spark plug wires, the spark plugs on this car are very easy. So these are here, spark plug wires are here. The only thing I really need to do to access them is take off the charge pipe, because I'll have drive-by wire here. Charge pipe starts here with alpha lock, bends over, boom, done. So I really tried to take my time on the design of the simplest things that might not be the most aesthetically pleasing, but are more functional. So let me kind of explain that, because it's a really big thing. This fuel pressure regulator is at a very odd appearing angle, right? You would think, why the heck, Ryan, what in the fuck were you thinking putting this way at an angle off a JDL bracket for whatever reason? Well, this adjuster could have been upright. And what really comes down to is this oil filter needs to be accessible. This clutch line vent needs to be accessible. This clutch line itself has to be, clearance of something. When all of this was upright and trued up, it did not fit to where everything was accessible here. And if it was, then it didn't fit here. And so somehow, magically, a little bit of just, I don't want to say ingenuity, but just basic layout stuff made a non-visually pleasing but highly functional configuration to where everything's accessible, everything has clearance, and you could tell I've even got a map line right here. So it is tight. This would be hitting right here if this is all the way up. So that map line goes to right here. So it is just 20 gallons of shit in a 5-gallon bucket, as always. But I would prefer it this way versus, I guess, small fuel lines or undamped fuel lines or, something that wasn't going for all-out data acquisition, because I've got, coolant pressure. I've got, 30-something different sensors overall on this car. So we're definitely going ham, okay? So the next thing on this car, you guys could probably see the bash bar. All right, the bash bar is integrated with the lower part of the V-mount with the AC condenser, the dual oil coolers, the 2 front CSF fuel cooler and power steering cooler. I'm gonna sneeze. And that needs to drop out. I need to end up helicoiling this front right here. This hole somehow got screwed up. So this whole front assembly, these terrible temporary brackets, which will be integrated to a front splitter carbon fiber, all of this lower V-mount will have to come out. And then when that's out, I'll helicoil that part right there. And then I'm going to install at least 2 of these into the front pulley configuration. Currently, this only has 2 bolts in it. And I would love to do more R&D to help you guys out for a 60-2 trigger wheel that I did here. And this idea was specific to the Series 5 and Series 4 FC block. And the idea is that you have a far higher resolution than even the FFE configuration. So 5 times over factory. And 6 rib is going to go directly to the alternator because now the water pump is covered with its plate. And so there is no tensioner. The only tension is going to be off of this arced piece of plate steel, which holds the alternator in place. So I would have loved to have this car on a serpentine style setup. However, Mazda doesn't want it that way. They want to have an individual belt for this and this and this. I really absolutely hate that. But because of the misalignment of each of them, that's just how the cookie crumbles. So, yep. Now I'm just going to be very patiently dropping this subframe, making those slight modifications. Then I will final install the intercooler, all the charge piping and stuff like that. It'll probably be a little easier to have like the turbo inlet and all that stuff installed while that's all dropped out. The big filter, which I know you guys have seen this before. The whale penis filter. Surrounded by boxes. It's a big filter. So that'll be handled. And then we'll probably have Cody back here in a couple weeks with the front half section of the harness done. Then we're going to go do the PMU integration from the rear PMU to the front PMU to the ECU. And that's going to be a lot of notes. Very fun exercise. At least exercise and patience. But I guess, let's see, I've got two other things I'm going to show you guys. One, for any turbo on a rotary engine, our oil pressure of these engines is extremely high to maintain the safety factor of the engine. So on an average car, we're going to say anywhere between 80 and 120 psi is like standard operating range. Okay. Your turbo, an EFR, is happy at 60 psi and below. Garrett's are happy at like 40 psi. Okay. These ball bearings are very sensitive. So a little small filter and regulator is all you need. The regulator is not adjustable. These are from TurboSmart. They're awesome products. Marty's a good guy. And essentially this will go off my oil feed. I'm not going to use this line, of course, but just temporary mock-up. This will go somewhere nicely tucked underneath the intake manifold on its bracket. Then it'll go to the oil feed here. So very simple, very easy. You don't have to reinvent the wheel. This will bypass back down to the front cover. The return line. So I have it's my oil metering line. I don't want to waste your guys' time in here. Anyways, this front line down here. So you can kind of see the fitting on the left-hand side. It's pointing straight up. So that's going to go to that fitting, and then it'll go right to the base of this oil pressure regulator with its little goofy bracket, which I have here. Not even gonna waste your time. So that'll work out nicely, and I'm excited for the rest of the week. I'm excited to see how it all ties together, and it's a badass car. So might as well give it the proper, I don't know, exciting pieces to finish it off. So I also have this over here, which I think is very appealing. Makes a lot of sense. Putting your engine builder stuff as a representative of someone who did the utmost best communication, and it's just awesome having one of these motors in my car. If you saw any of the artwork when this came together, I won't explain everything when it comes to the specifics of what is on here, but what I can tell you is this is a very, very special combination of different porting styles, and not a single one of this guy's engines, this is John Swide of Legend Motorsports, not a single one of these is the same. This is not a porting template dude. This is a guy who is calculated and puts pride into hand building a particular port for a given application. And you guys, you're probably looking at this thing like, look, Ryan, we've heard it before. We kind of don't get what you're trying to do. But this is a stage intake. We still notice stage intake. So when that upper is shut, I'll show you guys right now. When this upper has a vacuum signal pulled on this diaphragm, it's shut. Okay? That means every time it's got vacuum on, all of the 90mm drive-by-wire throttle body is going into just that small primary runner only. When the vacuum is released, the top opens. This, from here to here, moves. You're going to notice it in about a 200 RPM little blip when this goes from closed to open. So if you're accelerating, you'll see a tiny little boop, and within a 200 RPM span, that is perfectly opened. The timeline of that is, it's like 3/4 of a second. Not a huge deal. It's pretty much not going to affect as much as we think it will. But the point is, the primary runners on this engine that John did with me are like a medium street port with a extreme focus on port velocity, and the idea is to get this thing spooling as fast as possible. Also, without, obviously, the anti-surge valve, without surging. And the secondaries are a semi-peripheral port, downsized. There's this very specific shape to that. Also more internal working, so it's not a standard drop a hole in it sort of port. And then it's also a bridge port. So bridge port, semi-P, and street port. And the idea is that the outer two, when they open up, that goes only to the semis and the bridge port. When it's closed, it goes only to the primary street port. So we're playing with velocity. And one might ask, they'd probably say, what's the point of all this technology? You know, these are old platforms. It seems like a waste of your time. But this thing is built for war. These are 150 PSI clamps. These things will give zero fucks. They will not have boost leaks. They will not have any give. The vibration damping is going through the mounts, okay? So, this turbo, the whole Garrett G series, the efficiency and the equivalent sizing that this thing is. So, if we look at the EFR 9280, which is a fantastic turbo, that's a 73 millimeter inducer. This is just about the same size, and that would flow somewhere like 105 or 110 pounds a minute of airflow. The efficiency of that turbo, in any stretch of the imagination, was significantly lower than this new stuff. This new G42, even though they're saying the sizing is supposed to be whatever they're saying, it's between the 4294 and the 4202, the turbine side is so much more efficient that now the turbine sides are acting like a GTX 45. That means that this turbo will be laggier than what we're expecting it to be, which is why we have ample motor to move as much airflow as possible to handle these sorts of things. So this thing, even on pump gas, we've seen these things go past 625 wheel horsepower, which is just retardedly good. And it's a broad power band. The guy who did it is on a Bridgeport in UK, and I believe the Bridgeport is very much a template style. The torque and whatnot is not exceedingly good. But again, power band is fantastic, so it doesn't matter. Point being with this turbo is going to be a little bit on the laggy side. It's going to be a little bit big for the application. The car weighs 2,500 pounds. So when you have a turbo this size with this much airflow, it might start coming in about 4,400 RPM. However, here's the trick of all of this. I was not going to say this video, but I will. This car has an anti-surge valve. Well, what can I do with that? Realistically, since I have an upper and lower boost controller on this car, I've got dual 3-port Mac. I can force and request 50 psi worth of wastegate at all times, right off idle. And all I have to do to maintain boost is vent as much as I want until I'm reaching a past surge line effective region. So even though most cars that have this turbo might be laggy, because I have that control and drive-by-wire, it means I can kind of trick it outside of that. I can have RPM on this turbo far earlier than someone without an anti-surge valve. And where that really, really comes into play is the most important part. My mountain drivers, you know this, we shift constantly. And we're shifting constantly maybe for efficiency reasons or just to enjoy the car in different RPMs, but shifting on an anti-surge valved turboed car is going to be damn near epic because you're not losing shaft speed. If you're not losing shaft speed, the second you get back on the throttle, especially when your charge pipe is this long and this long, like compared to a front mount, this thing has no airflow between turbo and engine that's not cooled. It's a perfect system. V-mounts really are an exceptional design. They're freaking awesome. And it's just going to be a very interesting tuning project because this car has so much R&D going into it. So we've got, like I said, somewhere around 30 something sensors total. And the amount of controls are, I don't want to say infinitely stackable, but the programming that I can do on the M-Tron is immense. I can do this a million different ways, and anything that I want to change for axes or traction control or boost control, like I can change all of that however I feel the need to. So I'm looking forward to really getting into some more motorsport grade stuff, and I'll be sharing that, and I'll let that trickle down into all of my work. A lot of you have seen me do stuff that's already far above and beyond the norm, and I want to continue that trend. So we're just going to keep it rolling, and I really think it's going to be a fun process. So anyways, I'm getting tired. It's a long video, but I see a few things here I can improve, and while it might not be the most visually pleasing for all the line configuration, you guys can kind of see my justifications and why I'm doing a certain thing and why I think it's more important to do than purely a aesthetic value. So I'm going to get back to it. It is almost 3 in the morning, so I'll catch you guys in the morning for some tuning work, and then we'll get back to this in the evening. So, all right, y'all. Catch you in the next one. Cheers.